Hello, Assalamualaikum warahmatullahi wabarakatuh. Welcome back to my video. In this video, we will learn about bond enthalpies. So this is still a part of chemical energetics. So today, we will focus on how to calculate the enthalpy change using bond enthalpies. These are the learning objectives. Number one, understand that energy transfer occurs during chemical reactions because of the breaking and making of the chemical bonds. Number two, use bond energy to calculate enthalpy change of reaction, delta HR. And number three, understand that some bond energies are exact and some bond energies are average. So without further ado, let's start our class by reciting Basmalah together. Bismillahirrahmanirrahim. Exothermic reactions and bonds. During an exothermic reaction, heat energy is released to the surroundings. This happens because more energy is released, making new bonds in the product that is taken in breaking bonds in the reactants. There is therefore a net release of energy, which is measured as an increase in temperature. So this is the sample of reaction. We can see here, before the reaction, we have C double bond with another C, but after the reaction, it's become single bond. So there is a bond breaking here, and there is a new bond also formed. So in the product, there is additional bond between carbon and hydrogen. And for endothermic reaction, during an endothermic reaction, heat energy is taken in from the surroundings. This happens because more energy is used in breaking bond in the reactants than is released when bonds are formed in the products. There is therefore a net intake of energy, which is measured as a decrease in temperature. Mean bond enthalpy. The mean bond enthalpy is the average bond dissociation enthalpy for a particular bond in a range of different compounds. Precisely, it is the average enthalpy change for breaking 1 mole of a particular bond in a range of different compounds in the gas phase. Using the mean bond enthalpy takes into account the different bond dissociation enthalpy of the particular bond in different compounds. So delta HR equals to enthalpy change for bonds broken or reactant minus enthalpy change for bond form or products. So that's the formula that you need to remember. Please take a note. And then to make it clear, maybe better for you to also know about the energetics limitation. The mean bond enthalpy is the average bond dissociation enthalpy for a particular bond in a range of different compounds. Precisely, it is the average enthalpy change for breaking 1 mole of a particular bond in a range of different compounds in the gas phase. For example, the bond enthalpy of O and H bond in a water molecule, H2O, is an exact value because it can be directly determined experimentally. The carbon and carbon bond in organic compounds is an average value obtained from considering a variety of carbon-carbon bond in different molecules. It represents the typical energy required to break a carbon-carbon bond in various contexts. Okay, so let's look at the types of questions. This is the types of question about the enthalpy change. So if you want to calculate the enthalpy change using bond enthalpy, you need the bond enthalpy data. So the challenge here is you should be able to show the structure of the reaction. Here is the reaction. You have to convert this chemical formula into the structural. What is the change of that formula? So here is the sample C3H8. So you need to know what is the C3H8, what types of hydrocarbon is that? Because of it's following the formula of alkane, so it's alkane, and then there is no double bond inside of it. So this only contain of single bond. And then you need to draw the structures of all the compound. That's the challenge in this topic. So this is the look of C3H8. And then after that, continue to the next reactant, that is O2. So since you have coefficient there, means that you have 5 O, double bond with other O. And then go to the product, we have CO2. So this is the reaction or the structure of CO2. And then it will produce H2O also. So the coefficient will affect the number of it. So you need to include the coefficient when you want to calculate the enthalpy change. After you're done, draw the structure. You have to count the number of bonding one by one. So here we have 8 bonding of C and H, right? So you have to count it one by one. And then we have also a bonding between C and C also. Since we have 3 C there, so we only have 2 C and C bonding. So be careful. It only counted as 2 carbon and carbon bonding there. And then you need to get the data. So just get the data from the booklet and then substitute it. Substitute into this. And then at the end, you have to count the total of the reactant first. And then also count the total of the product. So to count the delta H, you can use the data of the reactant minus the product. So final data or final result is this, minus 2034 kilojoule per mole. So this is the delta H when we use the bond enthalpy theory. Okay, so yes, that's the formula. That's how to use the bond enthalpy theory. So just count the total of bond energy in the reactant minus the bond energy in the product. Okay, so yes, that's it. Next is for your practice. So I give you a question, so you can solve this question to practice on how to use the bond energy for finding the enthalpy change. I think that's all for today. Let's close our session with reciting Hamdalah together. Alhamdulillahirabbil alamin. If you still have a question, do not hesitate to ask me. And yes, thank you everyone, and see you in my next video. Assalamualaikum warahmatullahi wabarakatuh. Bye bye.